All right. So, guys, are you able to see my screen? Is the Python lesson 2 0 to operands or operators are visible?
Yes, sir.
Just give me a thumbs up if you are able to. Okay, you are able to see it. All right. So, so today we will start with some of the inbuilt functions that are available in Python. So far, we had seen print functions and the basic operators, how to be used with numbers is what we have seen. And apart from print functions that are there are also a lot of inbuilt functions that could be used on the numerical values, right? So that is where we'll get started. So we have the first function as div mod. So we pass numbers to it. So I pass something like this, div mod 5, 3. And this gives us an output as 1, 2. Now what this represents is that 5 when divided by 3, right? We have two things that are being returned, right? The remainder is 2 and the quotient that it uses to multiply with 3 is basically 1, right? So 3 ones are 3 and the remainder is 2. So that is what we get here. Div mod of 5, 3 gives us 1, 2. So that is what div mod does. Div mod helps us try to find out the output of the division and the modulo operator. Both of them together, it performs this. This is where sometimes Python is kind of, flexible in terms of giving the output. We'll see more of these similar outputs when we get into functions, right? So we see two different outputs being generated from a function, 1 and 2, right? Two values are being given as the output. So that is what we see here. And similar kind of functionality we'll see as we go further. And then this is something called as packaging and unpackaging. When we enter functions, we'll see these kind of things, right? And also when we pass values to functions as well, we'll be able to use them. All right, so the next thing is ORD. So ORD is a function that helps us give us a output based on the input that we are providing to it. And the input is essentially a character and the output is a number. So what ORD does is for a given character, it gives us a Unicode output. That is what ORD does. So a Unicode output value is generated. And for H, the value is or capital H, because there is also lowercase h and a capital case H that could be used. For the uppercase H, right, or the capitalized H, we are getting a value of 72. Right, that is what we see here. Similarly, if I pass ORD and pass a value or the character A, the value that we get as an output is 97. That is what we get here. All right. Similarly, if we pass, let's say, capitalized A, now the value is 65, right? So this is what we get the output as. And we can pass some other characters also, so that, just give me a minute, guys. Right. So as we see here, we get the values here as the output, which is essentially a Unicode value. 65 and 97 are Unicode values of characters lowercase a and uppercase a, right, respectively. Similarly, when we do this ORD of \n, right, this gives us a value of 10, right? So again, I would request all of you to follow along with me. Please try to run the statements in the Google Colab notebook, or if you have got a chance to look at the installation document that was shared in the WhatsApp group yesterday, you could download that software and then you will be able to start executing them in the local environment itself on your machines or on your desktop, right? That is what this would be helpful for. Right, so that is where we will be able to use them and run this. Okay, so the interface that we are using right now is Jupyter Notebook, but as we go further, we will try to use an ID itself that is used in the industry. This is essentially, for interactive purpose, Jupyter Notebook is used. But if you want to develop Python files as such, right, the extensions would be .py, then that would be helpful, right? And the latest version of Python is 3.11. And if you intend to download only the Python version, I would request you to download one version lesser than the latest version, is because sometimes what happens in the latest versions, all the bugs are not fixed and it might not be compatible with other libraries. For these sessions that we are doing, they should be okay. But if other libraries are used, probably that might not be really compatible. It is always preferred to use one version lesser than the latest version because of some kind of fixes that might not have gone through. So use 3.10 if you're trying to download Python. 3.10 should be sufficient. 3.11 is the latest version that we have. And as far as Anaconda is there, I have provided you a link. You can download that. That is anyways for 3.9 and 3.10. That could be installed, and all the libraries that are needed are packaged into Anaconda, right? So if we use Anaconda, right, this is the website that we have, Anaconda. And if you go to the first link, right, this is the complete packaged Python libraries that would be available, and you can download it from this website. Okay, this is where we'll be able to find the complete package thing. And as you see here, because my OS is essentially Windows, this shows up the Windows download installer. But if it were Apple or probably Linux, that would come up here and we can start downloading it. Right. So this is something that would be really helpful. You can download from here, and the instructions for this is pretty straightforward. The set of screenshots are already there in the link provided in the installation document, and this could be used. And then once you use this, so Anaconda, please download. That would be, there is one question from one of the participants that the question is, should we download both Anaconda and VS Code, or any one is enough? So VS Code is basically an IDE that stands for Visual Studio Code that does not come with Python as such. It is basically kind of an editor, just like Notepad or Notepad++ that we have. VS Code is also an editor that is used for programming purposes, right? So that will not have Python. So what I would suggest is basically use this Anaconda. Please download Anaconda first and then download VS Code. VS Code will also be helpful. So download both of them, right? Probably in one of the classes, I'll also run through how to use VS Code. But then with Anaconda, there is also an IDE called as Spider that would also be needed. So hence, please download Anaconda and VS Code both, and both of these would be needed. Fine. VS Code alone would not be sufficient. We would need Anaconda anyway. So please download both Anaconda and VS Code. All right. So that is what would be needed as we go further. But in case if the software is not ready, we can still use this environment, collab.research.google.com. This would still help us, without installing any software on our machines, try to run what is provided in these sessions. The notebooks can be run in the Google Colab environment as it is without really installing anything on our laptops. That is also sufficient, right? That is where we will be able to use the Colab environment. All right, so that is about Jupyter Notebook and how this Jupyter Notebook is being used on the local environment. And I'll also go through the steps of spawning a Jupyter Notebook once you have installed. Probably tomorrow or sometime later, I'll also show you how to open up the Jupyter Notebook and also how to use the VS Code as we progress in the upcoming sessions. Okay, so hope everybody is able to run the ORD function. The next function that we see is called as a CHR function. So if we pass any character or the number as it is, let's say for the character, CHR of 10, that would return as the character back, right? It would give us \n. So previously we had ORD of A giving us 97. So let's pass 97 to CHR and see what would be the output. So we would get the output as A, lowercase a. That is what we see as the output, right? Similarly, if we pass CHR of 65, right? Or 65, this should be without the quotes, 65. And then we would get uppercase A. That is what we would get the output as. So 97, when it is passed, we get lowercase a. And when we pass 65 to CHR, we get the uppercase A. That the character is returned. And there are a lot of other characters that could be generated. So if I use 1024, right, it provides us some pound symbol, or an inverted pound symbol. And similarly, if you use 8541, right, if I try this, right, it gives us a percentile symbol. So based on the Unicode value that we are passing to CHR function, the respective character is outputted, right? So there are different values that could be passed, and it is similar to ASCII code, but this is called as a Unicode value that needs to be passed in, because for different characters, there are different Unicode values, and this would be outputted. All right. Everybody ran through this. I'll wait for another 1 minute, and then we can go ahead with the ID function. So there is one question which says, what is the range of numbers that we can use in the CHR function? So right now, the number of values that we can provide to CHR function is still hexadecimal format. So till 110,000 numbers, we will be able to provide the values to CHR function. That is the range of the values that we can provide. All right. So you can try 111,000 also. That would also work. And then there is after that, I think it is 400 and some number. Till that particular value, it will be available. Okay, so that is, it accepts different kind of characters. So till that particular value, the range is available from 0. Again, it starts from 0, and it is available from till 110,000 or so. Right? So that is the range of CHR function. And then we move on to the next thing. Till here, any questions, guys? Is everybody able to complete this? All right. So next we have the ID function. So when it comes to Python, right, there are 3 kinds of Python internally that keeps working. One is called as CPython. Then we have something called as JPython, and there is something called as IronPython, right? So what is the difference is that CPython is the basic Python that we are trying to use. So internally, a lot of the stuff that has been written is basically C programming language, and then on top of it, the syntax has been evolved. So Python is essentially implemented using a lot of C programming language, right? So that is what C Python is all about. And then we have JPython. This is essentially Java, Java-based Python. So if you want to connect to Java or JVM and then run Python, then we'll be able to use this. And then this is for .NET. So we have .NET also. This is called as Iron Python. So the .NET framework, if you want to use it, then we'll be able to use the Iron Python. So there are 3 different kind of Pythons that we can use. And what we are trying to use right now is basically the C Python version, right? So when we try to use this, right, let's say a variable X has a value of 10 or 10 has been assigned to X. We want to know the location where this particular value is stored. Then we can use ID, and there is nothing but the memory location that CPython uses to store the value of X internally. And as we run this multiple times, right, the value of the memory locations keeps on changing. So this is the memory location address at this moment that has been allocated in the RAM, and the value is this number, this huge number that is being generated, right? Similarly, for a floating value of 20.5 that has been assigned to Y, I want to find out that. Now, where is this helpful is when we try to do a reassignment, right, for Y or X, and then try to find if it is occupying the same memory location or not, then we will be able to verify that as well. Let's say we do something like this, Z is equals to Y, and then we do print ID of Y and then print ID of Z. Right, and as we see here, the output that is being displayed, right, it points to the same memory location, right? That is what this indicates. What we have done is we have assigned 20.5 to Y, and then Y has been reassigned to a new variable called as Z, right? And one important thing that we note here is that we are not specifying any type of the variable names. What I meant by type is, if we try to do this type of X, it says int, and similarly I try to run type of Y, right? It gives us float. So we are not mentioning that Y should be of value float, or it should be of type int or float. We are not specifying anything. All that we are saying is variable name is equals to the value. So Y has been assigned a value of 20.5. Now I assign Y a new value. Let's say I assign it hello, right? And then I also provide this print of Y now. And I also check print of ID of Y. Right? So there are 4 different things that have been printed. The first value is essentially the ID of Y. The second value is essentially the ID of Z. Then hello is printed, and then the ID of Y is being printed, right? So this is what is being printed as output, correct? So what this means is that we can assign a new value to a variable in Python programming language, and this new value can be of different type. What is a different type? Initially, it was a float that we have assigned, and now we are assigning a string value, right? This is what we are trying to assign. So float value is assigned to Y, and then we are reassigning a new value hello, which is a string, to Y. And we also see the memory location of Y is different when it has been assigned hello and what it was previously when it was assigned 20.5, right? How do we know that? We printed ID, and it gives a memory location. This is value that we see here, this big number that we see here is nothing but address or the memory location. That is what it is. How, or it is kind of an address that it stores in the memory. This value indicates the place at which it is being stored, right? Or the identification value where this particular value 20.5 is being stored. That is what we are trying to get this. And this is what is Python returning. And this is essentially done by CPython internally, allocate some space to a value, and then it returns us this particular address, or what is called as the memory location. And we see for hello And for 20.5, there are two different values, this one and this one, right? So what does this mean? First thing is the address locations are different for different values, even though the variable is the same. Point number two is we can assign any type of value to this variable, and this kind of programming language are called as dynamically typed programming language. So Python is basically a dynamically typed programming language, right? That is what it means. We have something like this. We are trying to assign values, and then we want to reassign a new value to it, and that is possible in Python. It need not be of the same type. The new value that is being assigned need not be of the previous type. What does this mean? 20.5 was assigned initially. Now we are assigning hello. So the type of hello is string. Originally it was float. So this assignment, where we are able to assign different type of values to the same variable, is nothing but a dynamically typed programming language, right? In some programming language, this is not allowed. And such programming languages where different types are not allowed are statically typed programming language, right? So Python is a dynamically typed programming language. Dynamically typed programming language. That is what Python is. All right. Questions? Any questions on ID? What we have done and how Python is referring to a different memory location as the value is being changed with respect to a variable. Is this clear, folks? Any questions on this? Are you able to run this and see for yourself? All right. So that is what we have done. And next, we'll see what is called as the bin function. Okay. Now, let me pass value 10 to the bin function, and we get the output as 0B1010. That is what is the output that we get here. What does this mean is 10 is represented in base 10, right? We know base 10 numbers have value starting from 0 to 10, correct? It starts from 0 and ends at 9. I'm sorry, not 10, 0 to 9. And the next value is 10, right? So what does this mean is any number can be represented in something like this. 10 into the number, right? This is the unit digit, plus 10 to the power of 2 into the tens digit number, plus 10 to the power of 3 into the hundreds digits number, and so on, right? This is what we try to do with respect to base 10, right? This is how a base 10 number will look like, right? We have units digits, tens digits, hundreds digits, thousands digits, etc. Right? That is what we have. But when it comes to a different base, right? Let's say binary. Bin indicates it is a binary base. What is a binary number? Is that it has only two values. A binary number will have only two values, right? It is essentially 0 and 1, right? So anything that would start would be 2 into the first value, right? And it starts from the left. Anything that we try to do, it starts from the left. I'll explain what it means, first value and etc. as we go further. For now, this is the representation, 2 to the power of 1 into second value, and so on. So what are the numbers that we'll have in base 2 is that we'll have only 0 and 1. So first value, if it is 0, we multiply with 0, and 2 into 0 or 2 to the power of 0. Let me try to put this much more clearer. This would be not even this thing. It would be 2 to the power of 0. And then the first value 2 to the power of 1, and so on and so forth. That is how it would be. Even this one, I think I missed this. So this would be power 0. This would be power 0 into units digits, power 1 into tens digits, and hundreds is 2 to the power 2, not power 3. This is how it would be in base 10. And for any base, it would be the number to the power of 0 into the first value plus number to the power of 1 into second value, so on and so forth. So for any base, if it is base 3, you'll have 0, 1, 2. Base 6, it will be 0, 1, 2, 3, 4, 5. Base 8, it will be 0, 1, 2, 3, 4, 5, 6, 7. Base 16, it will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it will start with A, B, C, D, and E, and F. So that is how it will go for base 16. So generally, when it comes to computers, right, we use the bases as binary, octal, hexadecimal, and sometimes base 10, right? That is how the representation is. And for a computer, it is basically binary. The language of computers is binary, and it is essentially zeros and ones. Now, why is this important is, what we're trying to do with this bin function is that we are passing 10 to bin, and it is outputting a value something like this, 0B1010. What does this mean is, the first two values that you see here, 0B, it indicates it is a binary representation. These two indicates a binary representation. And the value in binary is 1010, right? The value in binary is 1010. So if we want to convert this 1010 into representation in base 10, what we do is we start from left, okay? And how is it represented? So let me also show that. So we'll have something like this. This will be 2 power 0. This will be 2 power 1. This will be 2 power 2. And this will be 2 power 3. Okay. So we'll have something like this. 2 power 0, 2 power 1, 2 power 2, and 2 power 3. Or 2 to the power, right? 2 power means 2 to the power, right? Exponent. So now 2 to the power of 0 is 1, right? And what is the number that we should multiply is basically this number. This is 0. And then we do an addition. The next number is 2 to the power of 1. So we take 2 into what is the multiplier for it? It is 1. Okay. Plus 2 to the power of 2 is how much? 4 into this is 0. Okay. And then we have 2 to the power of 3, which is 8 into 1. Right. So when we sum this up, first value is 0. So this is 0. Plus next value is 2. So plus 2. Then we have 4 into 0 is 4. And then we have 8 into 1 is 8. No, sorry, 4 into 0 is 0, guys. I'm sorry. And 8 into 1 is 8, right? So essentially we have 0 plus 2 plus 0 plus 8, which is nothing but 10. And that is what we have passed it, right? 10 was passed. In binary, we are getting this representation. Okay, that is what we did. Similarly, if we pass, let's say, bin of -10, then it would represent the same thing, right? Minus of this representation. The first two letters indicates, or the characters indicates, it is basically binary representation, and its binary value is 1010 in binary format. If you want to change it, then we have to use this kind of a formula that is mentioned here. We should use the base 2, multiply with the respective number wherever it is located. So for the first number, it is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. From left to right, we have to do this, right? That is how we will be able to get the original value, what was passed in bin. So bin gives us the binary representation, and our output is basically a string value, right? It gives us a string value. So if we want to convert this into an integer representation, first we have to remove these two values, these two characters, and then only use the other characters or the other numbers that remain in order to convert that into some other base. Okay. That is what bin helps us. Similarly, we have hex. Hex is basically hexadecimal representation. So when we use value 10, we get 0xa. Why 0xa is because we have numbers from 0 to 9, and then it is A, B, C, D, E, F, right? This is what we'll have. So 10, so 0 to 9 is done, and the next is A. So we see A. 0x is nothing but hexadecimal representation. A is nothing but the value 10. Fine. That is what we see here. And hex of 10 gives us this particular string output 0xa. 0x indicates hexadecimal and A indicates that it is the 10th value in the hexadecimal format. Similarly, if we pass 23, let's say, we get 17. Now, how to understand this 17 in hexadecimal? So 7 into 16 to the power of 0 plus 1 into 16 to the power of 1, right? So this is 16 plus 7 or 7 plus 16. Let me write it the correct way. So we get 23. The value is 23. 7 into 16 to the power of 0. 16 to the power of 0 is 1. So 7 times 1 is 7. 1 into 16 to the power of 1. So 16 to the power of 1 is 16. 7 plus 16 is 23. Hexadecimal representation of 23 is this particular number. Or if you want to convert this into base 10, 23 is the value. Fine. So similarly, we can pass some other values as well. Right? Let's say I pass 17, then we get 0x11. Right? This is hexadecimal representation. So request you to try this out quickly on the Google Colab notebook. I'll give you about 2 minutes and then we'll go to OCT function or the octal function. Okay, so let's get started with OCT. OCT is nothing but representation in the octal format. So if you pass 10, you'll get the octal representation as like as 0, 0, 1, 2. So again, this is 2 into 8 to the power of 0. Right? Plus 1 into 8 to the power of 1. Right? 8 to the power of 0 is 1. So only 2 remains here. 1 into 8 is 8. 8 plus 2 will be 10. Right? So that is what we are passing here. And in octal format, that is 1, 2. Right? So that is what we get here. Similarly, we pass 15 and then we get the representation in this format. And we can try others as well. I pass 13 and then we get the representation in this format. Okay, so this is how we represent numbers in Python in different bases, right? We have taken binary as the base, then we have taken hexadecimal and then the octal representation. So this is where int function becomes much more easier to represent the values as well. So by default, int takes the base as 10, right? So if you pass int of 10, it will give us 10. Or if you pass int of string number, it will give us 10, right? There is something that we have seen in the previous sessions, right? This also gives us 10. So if you pass 10, it gives us 10. But if you pass a string value, it gives us the base 10 representation of that string value. By default, the base is 10. But if we want to change the base from 10 to some other base, let's say we want to change it to 2, we can do it using this int function. So I pass 10, but the thing that we have to do, take care is whenever we are using some other base, we need to represent the original base number in strings or for whatever base that we are using, it should be represented in strings. So we are using base 2 and this string representation is also in base 2. That is what we are trying to do here. Okay. So this output that we get here is nothing but the value that is there in base 10, right? That is what we get the value as. The output that we get is base 10, but the base that is being used is 2 and the representation is also with respect to this base that is being provided. So 10 is in base 2, base 2. This is not in base 10. Guys, everybody clear till these two steps with respect to int function? All right. So that is what we have done. And similarly, we'll pass some other values, right? And then we pass base 2. So this representation is in base 2. So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. So 1 into 2 to the power of 4 is 16. And still we have 1 into 2 to the power of 0, which is 1. So 16 plus 1 is 17 in base 10. So that is what we get as the output. In base 2 is this representation, 17 is in base 10. Okay. Similarly, we can use some other bases. So let's say I use some other bases like 16 itself. So I say base is equals to 16. And then we get the value as 10 because we know A in base 16 is 10, right? 0x indicates this is base 16 and A indicates it is basically 10. After the 9, we get 10 and that is represented as A, right? That is how it is represented. So let's say we have the base something like this, right? This is what is represented in base 8 and we want to get the original value in base 10. So the value is 13. This is something that we have done previously. So this is how some questions might be given in some of the competitive exams. Let's say we are given a sequence of steps and then we want to convert it from one base to another base and then we want to run the output. Then this is how we will be able to do so. directly pass the number that is there in the original base and then pass it to int. That will convert it into base 10. From one base to base 10, we'll be able to do that easily in Python. If the question states that we should not be using any of the inbuilt function to convert one base to another base, then we have to then we have to extract the value, compute the formula that has been provided, or use the base appropriately as you have done previously, multiply the numbers, sum them up, and then try to find the output. Right? That is what we have to do. But then this becomes easier compared to other programming languages. In other programming languages, not such inbuilt functions are there in order to convert from one base to another base. This is slightly easier in Python. That is one advantage that we see here. Okay, similarly, we had done 23. So I'll try to run that as well. And then I provide base is equals to 16. Sorry, I think this should be base. So we get as 23, right? Right, so hope this is clear. And we'll move on to next function, which is called as ABS, which is nothing but absolute value. Now, absolute value, we know as we do it in mathematics, essentially is that it is just like that modulo that we apply, it gives us the positive value output, right? So if I apply 10 minus of 10.2, then it will give me a positive value. Similarly, if we pass absolute of a positive value, that will give us a positive value itself, right? That a basic mathematical function which gives us a positive output that has been passed to ABS, or a positive numeric value that has been passed to A, or any kind of numeric value that is being passed to ABS, it gives us a positive value as the output. All right, so the next function that we look at is POW, which is nothing but power. This is similar to exponential. So we need to pass two values to POW. The first value is the base. The second value is the exponent. Okay. So 2 to the power of 3 is 8. That is what we get the output as, right? 2 to the power of 3, we already know is 8. So if I say print 2 to the power of 3, this also is the same thing. And what we are doing is also the same thing. But if you want to write it as a function, we can use this as power, base, and then the exponent. This looks like a functional way of doing it. This looks like a mathematical operation, right? That is what we will be able to do so. Similarly, if you want to write 3 to the power of 2, then we can do is power 3 and then the base 3 and the power as 2. That is what we'll be able to put. This is some of the inbuilt functions that we have seen so far. The next function that we are going to look at is basically minimum, and minimum takes multiple values, and then it gives us the output as the minimum of those multiple values that we pass, which are basically comma separated. So how do we use this is minimum of, let's say I have minus 16 and then 3 and 5. So it will give me the output as the minimum of these ones, which is essentially minus 16, right? That is what we get the output as. Similarly, if I pass minimum of 2, 1, 3, then it will give me minimum as 1, right? The minimum value of these is 1. Now, if you want to do it quickly in Python, we can use these functions. But then if you want to, run it iteratively using decision-making loop, decision-making just like if or else blocks, then we'll be also be able to use them. That is also something that we will be able to do, right? Let's say I pass only one value like this, minimum of 2. We cannot find the minimum with respect to only one value. We need at least 2 values in order to find the minimum of the values that have been specified, right? So if you do this, minimum function throws an error that is this particular value that has been passed is not iterable. We'll see what iterable means as we go further, but it expects more than one value. That is what the minimum criteria for minimum function is. It expects more than one value. And it should be comma separated. Then we have max. So let's say I pass 3 different values, minus 5, 10, 30. And out of these 3 values that we have passed, minus 5, 10, and 30, the maximum is 30. So 30 will be outputted. Okay. So one more important thing that we come across in Python is what is called as indentation. And if the indentation is nothing but the space from the margin to the first character of the code in that line, right? If this space is not proper, then it will throw an error. Right now, this space is not needed. So I remove this space and then I execute it. It does not throw an error. So indentation is, organizing the code from the left margin properly. And we'll look at these aspects as we get into an editor. The editor that we are using right now is basically a Jupyter notebook that runs cell by cell. But this matters most when we use an IDE or a normal file where we try to edit it based on the spaces that we provide from the left margin of that file. And this would be discussed as we go further, right? Similarly, max of 1, 2, 3, and the maximum value is 3. So max of these three was 30, max of 1, 2, 3 is 3, right? Same with respect to minimum again. It expects at least one value. Sorry, more than one value, not at least. It expects at least two values in order to draw a comparison. More than one value, that is what it would need in order to find the min or max value from the given set of values. All right. So hope everybody runs this. Take about a minute and see if you're able to run them. I'll wait till then, and then we'll move on to length function. All right, hope you would have run this. So let me run the next set, which is length. So length of some value, let's say I pass Python, and the number of characters that this particular function has is 6. So this would output us 6 as the value. Similarly, if I pass, let's say, hello world, right, this would pass the output as 12, right? The output is 12. So hello world outputs the length as 12 with the exclamatory mark. So LEN stands for length. It is essentially used to compute the length of the given string value. In this case, integer or float would not work. It is essentially used for string values. The next string function that we are going to use is called as REPR. It is essentially, convert the particular representation into a string value. Much more application when we will not really look at how to implement it, but it has an application when we try to implement REPR function when we use object-oriented programming. That is where its application lies. But then to simply understand it, it gives us a string representation of the past value. So let's say I passed this is Tuesday, and this gives me the output as this format. It gives us Tuesday as the output. Similarly, if I pass or if I try to print using print and then REPR, right, and then I pass Monday, then this would give me the output as Monday itself, right, in single quotes. Just see the notation, what it does. It's trying to represent that as a string value and return it back. Okay, that is what it does. So REPR uses a string representation of what is being passed within it, and generally it is called as an object. But then since we have not discussed objects so far, I'll not use the terminology. We'll just call this a string that is being passed to REPR. Whatever is being passed, that is being printed out as a string value. Okay. Right. So there are multiple operations that could be done on string. Let's say we want to get all the characters that are available. Right, we want to get all the characters that are available, and where is this string used extensively is essentially in AI, artificial intelligence, and especially in the natural language natural language processing, this kind of string values would be extensively used, or this string library can be used when we use Python, extensively used in order to clean the data. There is a stage in artificial intelligence which is called as explorative data analysis. In such stages, this would be extensively used. The other aspect is, let's say we want to check whether a particular string input has certain characters or not, then also we can use this kind of representations, right? If the particular character is available in string or not, whether we want to know if it is alphanumeric or not. So there are multiple ways in which we can use them. So one application is this as well. So in order to use string operations or string functions within Python, we import like this, import string, and then on that we say string dot, I want to get all the alphabets, right? So I say ASCII underscore letters, right? It gives us the lowercase as well as the uppercase alphabets. About 52 characters are there, and it is a string representation. It is put in a single quotes, right? Let's say we want to only get the lowercase one. So we'll say lowercase ASCII underscore lowercase, string dot ASCII underscore lowercase will give us the lowercase letters in this fashion, right? That is what would be given to us. Similarly, if you want to kind of get uppercase, then we can say string dot ASCII underscore uppercase, right? Then we get the uppercase values in this format. Similarly, if you want to get the digits only the digits, then we can run like this, string dot digits. This will give us a string representation of 0 to 9, right? That is what is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are enclosed in string, in quotes. Similarly, if you want to get hexadecimal digits, then we will be able to do this. So hex digits, and then we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, A, B, C, D, F, A, B, C, D, E, F. So this is essentially the output for hexadecimal digits. For octa, let's say we want to get the digits. So we say digits dot oct digits, right? Sorry, string dot oct digits. So we get the values as 0, 1, 2, 3, 4, 5, 6, 7. So we get the representation like this using the statement. And what we have done is we have imported this, right? We have imported string, right? Certain pieces of code are not directly available to execute. In such cases, we import those. And what we import is essentially a module, but what is a module and a package we will discuss as we go further. For now, if you have to use string, we just write this statement, import space string, in order to use it. Okay. And let's say we want to clean a particular text which has certain characters like this, like exclamatory mark, hash symbol, like especially when we are on the social media platform. The names are generally prefixed with certain characters like that, right? Like hash or some emojis, etc. So sometimes we want to clean the text to get the exact text that is being printed out, which makes sense, right? Which has some meaning, some word that has some meaning. So we want to extract that. So we want to see what kind of other things could be cleaned. So probably we want to clean all the punctuation marks that are there, and that could be accessed using string dot punctuation, right? That will help us get all the characters to be used, and then these characters can be used for cleaning. I mean, we can process these characters into our code and then start using them, right? So take a minute and try to check if you have any questions on these operations that we have done on string objects so far, or string values so far. All right, hope you were able to execute them. So let's get started with the next set. So we discussed already that if you want to represent text, we can represent that in single quotes or in double quotes. So I represent initially here in single quotes. So I say 2D con has two words, that is 2D and con. So that is what I represent here. And then we can do the same thing in double quotes. So I say text underscore D underscore quote is equal to double quote. And I say 2D con has two words. Right? And the same thing could be represented. And if you would like to print the statement out, we can put that as the last statement in the cell, and then the output is generated for that particular variable. So similarly, I do this for this particular statement as well. I put the variable as the last statement, right? That is what we do. And we can represent them in triple quotes as well. So we can do that in this fashion. So I use triple quotes in order to write this as multi-line. So I say 2D con has two words, 2T and con. So now this kind of represents in multiple lines, and that is what would be represented in the output as well. So we get multiple lines in this fashion, right? Because we have \n, first line is we have a carriage return, and then this is what is printed has two, and then we have another line here. We see the \n, and then 2T and con, and then a \n. So we see there are multiple \n's indicating that this has been printed out in multi-lines, right? That is what it means. \n is essentially used for that particular purpose to indicate that it is a new line. That is what we are trying to see in the output as well, right? So if you want to use multiple line string, then we can use that in this triple quotes. That is what we could use, right? So this is something that we have covered previously as well. Just to refresh that, because we are dealing with string, I put this here, and then we can look how this could be used as we go further. All right. All right. So the most important aspect of string is that it is immutable. String values are immutable in nature, right? So string values are immutable. We cannot change them. Cannot change them, and also these are accessed, or the string values can be sliced and accessed using indices, right? That is something that we will be able to do. So let's say we have some string values called as prep_has, okay? And then the first value that we can access is from index 0, right? The first character is from 0, then it is 1, 2, 3, 4, and 5, right? The length is 6, so it is from 0 to n-1 would be the index values or the indices, right? So we use a colon operator in order to access the index, or we want to specify certain characters to be sliced. What it means is, let's say I want only PRP. So I use 0 to 3. And how do I represent 0 to 3 is what we'll try to understand here and how it can be done. Okay. So let me try to first get some data. Okay. So I have this particular text already. So I take this text and I call this as text underscore data. I assign this particular text to text underscore data, and we want to slice it. When I say slice it, we want to get only a portion of it. And the index starts from 0, and then it ends at, let's say, 5. And this is essentially, when we say 5, this is 1, 2, 3, 4, and 5. It is not at the sixth character. It is only till the 5th character. That is what it does. It extracts till that point. So 0, 1, 2, 3, 4. That's it. This particular value is extracted. 5th is not included. That is what it means. Right. So something went wrong. Name text underscore data. I'm sorry. This should be text underscore data. So we extract in this fashion. So we get QT, right? So text underscore data 0 to 5 is what is extracted out. All right. Similarly, if you want the entire text, right? The entire text, we can either use text underscore data as it is, right? It will anyways give us the entire data. But if you want to represent that using the indexing scheme and also specify the colon, then we can do something like this. So print text underscore data. Right. So we can specify something like this. Yes, let me see if this is coming up. Okay, yeah. Right. So this is how we can specify. Both of them mean the same. Right. So this is how we'll be able to specify. And let's say we want to get only a particular piece of text, right? So I get to 0, 1, 2, 3, 4, 5, 6, 7, 8. So I want to get has, right? So what I'll do is I'll specify something like this, text underscore data. And then I specify 8 till say 12. And then it gives me has. All right. If I do 9, then probably that space is also eliminated. We see a small space in this. So instead of 8, I give 9 here. And then it gives me has. Right. So this is how we'll be able to use the colon in order to slice the data. And this is essentially to extract the piece where we want to start from in the text data, which is a bigger text. So if you want to do that, we can do that using the indices as well. Right. So this is how we'll be able to get or extract data from text, right? So this concept will again come back when we do lists as well. One kind of a data structure again. We'll try to see that later. But for now, this is also applicable to string as well. So this kind of representation using colon and indices can be done on string and as well as lists. As we get into lists, we'll see this representation again. So take a minute and see if you are able to run these. And if you have any questions, probably we'll discuss. Otherwise, we'll get started. We'll get going with the other methods that we have. So take about a minute. I'll pause here. So any questions till here, guys? If there are no questions, probably then we'll get ahead. So we have capitalize as the next function. So let's say I have something like this, tuticon, and I do capitalize, right? So what this capitalize does is the first letter or the first character of the string is capitalized, right? We get the output as tuticon. That is what we see here. So capitalize function capitalizes the first letter or the character of the string that we are using. Okay. And the next thing that we'll use is count. So let's see this. Let's say I have tutti-con has 2 words, tutti and con, right? This is my string value. And then I call the count function using the dot operator. And then I call con, right? What it gives is the number of times this particular string is occurring in this particular string. Okay. The substring con is occurring. How many times it is occurring in this particular biggest string? That is what it gives us. So con is available here. Con is available here as well. So it is occurring 2 times, twice, and that would be the output, right? So we get the output as 2. All right. So that is what count is. And we have another function called as center. So what center helps us do is, let's say we have tutti-con, and then I apply center, and the width of this particular thing is 12, right? Not 12. This is 0, 1, 2, 3, 4, 5, 6, 7, 8. This is essentially 8. Now I want to make this width as 12, and then I want to add something to the sides of it, right? Or starting of this particular word and the end of this particular word or this particular string, I want to add something and then still represent it as a string value. Then we specify how much big we want to make this from 8 to the next bigger value. So let's say I pass this as 12, and then I want to append space, or probably I want to make this with some other characters. Let's say I want to have hyphens, right? So what it gives us the output is 12 as the length of the new string. This is what we have passed. The original string is centered, and what is appended is this character at the end, right? We have 2 hyphens here and 2 hyphens here. That is what is being appended at, or suffixed and prefixed. The characters that we provide is suffixed as well as prefixed to this particular string. How many times? Depending on the length. Let's say if I give this as 14, right? So it will add 3 hyphens. 8 is the length of the original string, and 3 hyphens again here, right? So we have 3 hyphens prefixed and 3 hyphens suffixed, and still maintaining 8 as the length of that particular string is basically tutti-con. Okay, that is what we'll be able to do so. All right, so I think we will stop here for today, and then we'll meet tomorrow. Any questions so far? All right, then we'll meet tomorrow. Thank you so much. If you have any questions, please reach out on the group. See you tomorrow.